So page 29, question 43. Fifth. Okay, 43. We'll solve that question. But first you finish this question. So what is the answer? If external force is equal to mu Sn, if external force is equal to mu Sn, then block will not move. Acceleration 0. And friction will be mu Sn. When block is not moving, external force is mu Sn. It means both are balanced, external force and friction force. External force capital F, friction force small f. Okay, both are balanced. So both are equal to mu Sn. Both are equal to mu Sn. Correct? If external force is slightly greater, not very greater, slightly greater, like mu Sn is 10, suppose. So external force is 10.01, 10.02. Suppose. Okay, slightly greater, then it will accelerate, it will move. So friction is kinetic or static? Is kinetic. Friction is kinetic. Then mu Sn is external force and mu Kn is kinetic friction. Okay, because external force is slightly greater than mu Sn. So we can take approximately same mu Sn. So acceleration you can find using this. So mu Sn minus mu Kn is equal to ma. So what is the answer? What is the acceleration now here? 0.6 into n. Now n, what is n? 40. Correct. Minus mu k, so 0.5 into 40 is equal to ma. Mass into acceleration. So 4, 4, 4 cancel. So 6 minus 5. So 1 meter per second square. Acceleration is 1. Clear? Done. And what is the friction value? How much is friction force? Mu Kn. Friction is mu Kn. So 0.6 into 40. 24. Friction force is 24. Clear? So when it is accelerating, remember, when it is moving or accelerating, then it is a kinetic friction. Remember, it is not moving. Not moving means static friction. Moving means kinetic friction. Next, you write down, if moving with constant velocity, note down topic, constant velocity on rough surface, constant velocity on rough surface, like this, it is going with constant velocity. Constant velocity on rough surface. If velocity is constant, so what is the acceleration? 0. So external force and friction will be kinetic or static. Friction is kinetic or static? It is moving. So kinetic. So kinetic friction and external force equal. No doubt. So what is, how much is external force? Kinetic friction, you know what is kinetic friction? Mu kn. So how much is external force? Mu kn. Note down. Okay. Constant velocity. See, suppose this is at rest. Now this is constant velocity. This is constant velocity. Okay, clear? Acceleration means like this. Velocity increasing means acceleration. Velocity constant, slow movement. Slow movement is also constant velocity. Slow movement is also constant velocity. Slow movement is also constant velocity. Okay, clear? Remember. So see, note down. Next question. Suppose this block is 6 kg. It is moving with constant velocity using external force of 20 Newton. Block is moving with constant velocity with the help of external force of 20 Newton. Okay, how much is external force? 20 Newton. Like this, I am exerting 20 Newton force. So surface is rough. Surface is rough. Velocity is constant. Now calculate coefficient of kinetic friction. Calculate coefficient of kinetic friction. Okay, so calculate how much. It is going with constant velocity. Block is going with constant velocity. So how much is kinetic friction? Mu k n. And how much is external force? Mu k n. External force and friction both are same, equal. Correct? So this is the external force, this is the kinetic friction. And external force is given. So at normal value you can calculate. How much is normal? 60 here. So calculate mu k. So mu k into 60 is equal to 20. So mu k is equal to 20 by 60. 1 by 3. Note down. 1 by 3. 0.33. 0.33. Finish. Okay, clear? Understood? So block is moving with constant velocity. So external force and friction force equal. Okay, done? Okay, next. Suppose it is inclined plane. Now solve same question for inclined plane. Constant velocity on inclined plane. Constant velocity on inclined plane. Now this is the block. It is moving constant velocity. How much is kinetic coefficient of kinetic friction? Calculate. Okay. So suppose this is the inclined plane, and any object you give pen, any pen, no problem, scale or pen. So it is sliding like this. It is sliding like this, correct? It is sliding with constant velocity. Okay, constant velocity. So what is the mu k? Tell me. So how much is mu k? Tell me. Okay, draw free body diagram. Normal force, you know how much is normal force? Mg sine or cos? Cos. Very good. Mg cos theta. Down the plane, what is the force? Mg sine theta. And friction will be where? Up the plane. And kinetic friction? Kinetic friction. Because it is moving with constant velocity. So friction is kinetic. Constant velocity means net force 0. So what is the value of kinetic friction? Mg sin theta. And what is the formula for kinetic friction? Mu kn. Very good. So mu kn is equal to mg sin theta so kinetic friction is balanced. Kinetic friction is balanced with mg sin theta. Kinetic friction is balanced with mg sin theta. So mu k into n. How much is n? Mg cos theta. So mu k mg cos theta is equal to mg sin theta. Mg cancel. So what is mu k? Tan theta. Mu k is tan theta. This is the answer. Note down. Mu k is tan theta. So block is sliding. Constant velocity. So kinetic friction is mu k tan theta. If theta is 30 degree, so 1 by root 3. Theta is 60 degree, so root 3. Theta is 37, so 3 by 4. Theta is 53, 4 by 3. Theta is 45, 1. Correct? Tan theta. So mu k is tan theta. Okay, finish. Next. So this is a horizontal motion, constant velocity horizontal motion. Axial force 20 Newton. So friction force also 20 Newton. And friction force is mu kn. Here inclined plane. Inclined plane means along the surface mg sin theta. Up the surface friction, kinetic friction equal. Finish. And so mu kn is mg sin theta. Mu kn is mg sin theta. Okay. Mu kn mg sin theta. Okay. Now you solve this. 2 kg block on rough surface. 2 kg block on rough surface. Just start sliding. Just start sliding when 16 Newton force acts along surface. 2 kg block on rough horizontal surface. Write down horizontal also. Okay, on rough horizontal surface, just start sliding when 60 Newton force acts along surface and accelerate. Oh, sorry, not accelerate. And move with constant velocity when 14 Newton force acts on it along surface. Find mu s and mu k. Find mu s and mu k. Okay. So now this is the question. Okay. So 2 kg block is there. Suppose this is the surface. Block is there. Surface is rough. Okay. Okay. Now you answer. Now when it is just sliding, just start sliding, how much force is exerted? Just start. Mu s n. Okay. External force is mu s n when it is just starting. To just start. Okay, clear? Actually slightly greater, but you can take this also. To just start, how much force is needed? Slightly greater than mu s n. But for numerical, you can take this mu s n. So, what is the force you are exerting to just start? 16. So, calculate, and mass is given 2 kg. Normal 20. Normal is 20. So 16 is equal to mu s n. Okay, what is n here? 20. So what is the value of mu s? 4 by 5.8. Okay, 4 by 5.8. Very clear? Just start. To just start, how much force is needed? Slightly greater than mu s n. For numerical purpose, you can take mu s n. So when 16 Newton is acting, it is just starting. Just start motion. So 16 is equal to mu s n. N is what? 20. Okay, mu s got. And when it is moving with constant velocity, what force you are exerting? 14 Newton. So how much is friction force? When it is going with constant velocity, how much is friction force? Mu k. So external force will be same as friction force, mu k. Are you getting? Constant velocity. So both are equal. So this is given as 14. So mu k into 20 is equal to 14. So mu k is equal to 7 by 10.7. Okay, mu k is equal to 0.7. Note down. So remember, okay, 16 Newton force acting here. Just start like this. Just start. Okay. To just start, 16 Newton force needed. So 16 is equal to mu s n. And now it is going with constant velocity. So what is the force? 16 Newton, 14 Newton, 14 Newton. So what is the value of 14 Newton? Mu kn. Clear? What is the value of 16 Newton? Mu s n. Okay, finish, done. Just start, constant velocity. Just start means this, constant velocity means this. Okay. Okay, now solve the same question. Solve for acceleration. Solve for acceleration if external force is 20 Newton. Okay, solve. If external force is 20 Newton. Yes. Yes, ma'am. Okay, cool. Okay. So now external force is 20 Newton. What is the external force? 20 Newton. To just start, how much force is needed to just start? 60. Now you are exerting 20. Are you getting or not? So it will accelerate. Okay. It will accelerate like this. It will accelerate. It will accelerate. More force you are exerting. 20. So what force will act? Tell me. Friction. Friction will be mu kn. Mu kn how much? It is moving. Hmm. It is moving, right? See, just to start, how much force? Just to start, 16. But now I am exerting 20, like this. Understood? More I am exerting. Okay. So it is sliding. It is sliding. So sliding. So friction is what? Kinetic. It is sliding. So friction is kinetic. Understood? So how will you find acceleration now? And kinetic friction is mu k and 14. So tell me, acceleration how will you find? 20 minus 14 is equal to ma. So 6 is equal to 2a. A is equal to 3. Okay, clear? Okay, clear, understood. So you observe this question carefully. It is a very good question. Just to start 16, to move with constant velocity 14. So what is easy? What is easy? To move with constant velocity is easy, or to just start is easy? More force is needed to just start. To move with constant velocity only 14 is enough. To move with acceleration means velocity increasing, more than 16 is needed. Okay, so 20 Newton. Okay, understood? So kinetic friction is 14. So 20 minus 14 is equal to ma. Okay, fine. Now next question you solve. Suppose this is 3 kg. Now force acting is 4t. Time varying force it is. Time varying force. Okay. So mu s is given as 0.3. Mu k is given 0.2. Now force is acting time 0 means what is the force? 0. After 1 second what is the force? 4 Newton. After 2 seconds what is the force? 8. So force is increasing. Like force is increasing, say I am exerting force 0 Newton, 1 Newton, 2 Newton, 3 Newton. Okay, after some time it will slide. Now more force. Okay, more force. So force is increasing. More example of increasing force. Suppose You press something, you press like this wall, more force, okay, force you are increasing. So now you find time when it will start sliding. Find time when it start sliding. Find acceleration 2 seconds after it start sliding. Sliding means motion. Okay. So at what time it will start? Just start. So for to just start, how much external force to just start? Mu Sn. Very good. So solve. To just start, external force, how much external force? 4T. So 4T must be equal to mu Sn. What is n? How much n? 30. So 4T is equal to mu s into 30. So 9. So what is time? 9 by 4 means how much? 2.25 seconds. Okay. So at 2.25 second, it will just start. Just. It will start sliding. When it starts sliding, 2 seconds after that. So what is a new, what is the time value? 2 seconds after it starts sliding. At what time it is starting sliding? 2.25. This is clear. 2.25 second it starts sliding. 2 seconds after that. So what is the time value? 4.25. So 4.25. What is the acceleration? Now it is moving. It is moving. It is moving. So what friction will act? Kinetic or static? Kinetic. Very good. So kinetic will be mu kn, and right side force will be 4T, and time value is 2.25 plus 2. Okay, so that is 4.25. So 4 into 4.25. So what is the external force? 4 into 4.25. How much? 17. Good. 17. Okay, 0.25 you can separate here. 4 plus 0.25. Like this you can solve. 4 into 4, 16. Plus 4 into 0.25 is 4 into 0.25 is 1. 16 plus 1, 17. So external force is 17. Normal is 30. And friction force, tell me how much friction force? Mu kn. 0.2 into 30, how much? 6. So what is the acceleration? Unbalanced force is equal to mass into acceleration. 17 minus 6 is equal to mass into acceleration. Mass. So 11 is equal to 3a. So a is equal to 11 by 3. No, a is equal to 11 by 3. Okay, clear? So that's it. So this is friction. Now we'll do some questions. Okay. So now more concepts are there. Basic concept is this only. So just remember this. Okay. Just start mu Sn. and if force is greater than mu Sn, it will accelerate. So external force minus mu Kn is equal to ma. So I'm writing again. If F is greater than mu Sn, so it will accelerate, block will accelerate. So F minus mu Kn is equal to ma, because acceleration is there, so sliding is there. Sliding there means kinetic friction. Okay, mu Kn. Remember this. Okay, next vertical wall, note down. Vertical surface. Vertical surface. Till now it is horizontal surface, now vertical. So like this is vertical surface. So this wall is vertical surface. This book is sliding or not? Not sliding. So friction is kinetic or static? Static. Now it is sliding. So friction is kinetic. So see, this is the wall, rough wall, rough. Now this is the block. Now you are holding force like this. You are exerting force like this. See, I have to exert force like this. If I remove my force, object will fall. Suppose I want to hold it, I have to exert force. Correct? I am exerting force like this. So what force I am exerting? F, external force. Now normal is vertical or horizontal? Normal. Horizontal. Because surface is vertical. Surface is vertical, so normal is horizontal. Note down, normal is horizontal. Normal is horizontal. So this is normal. This is F. Mg will be downward always. Mg is always downward. Mg is always downward. And now it has tendency to slide where? Down, correct? Tendency to slide is down. So friction will act where? Up. So friction is up. So this is friction, not down. So friction is acting opposite to weight. Friction is acting opposite to weight. Be clear? Are you getting? See, like we'll give lizard. Lizard, you know lizard. Lizard. What do you call it? House lizard. What do you call? House lizard. Where you see house lizard? Where? On floor? No. Wall. They are always moving or rest? Rest. So what force is acting? Downward, what force is acting? Mg. So friction is acting where? Upward. But there is no force. There is no force. How it is holding the surface? Using what claw? What is called claw? You know claw? So lizards have claws, you know. How many claws? I don't know. You know better. How many claws? I know it is 4 legs. 4 legs are there. Claws are there. Like this, it is holding. Okay, so grip. So grip is there. That's why it is not falling. Okay. So or okay, fine. So Spider-Man also like that. Correct. Spider-Man also like that. Grip is there. So now you tell me, so friction is how much? Tell me, it is not falling, it is at rest. So how much is friction? Mg. So friction is mg. Friction is static or kinetic? Static. Note down. Static friction is mg. Direction of static friction is upward. Direction of static friction upward. And normal value is F. Note down. Fn, capital F is equal to normal. Suppose you are exerting 1 Newton here. So normal is also 1 Newton. If you exert 2 Newton, so normal is 2 Newton. Friction is mg. Now condition for rest. Note down. To keep block at rest. To keep block at rest, mg must be less than or equal to mu s n, because mg is pulling it down, friction is acting upward, and maximum friction we know. How much is maximum friction? Mu s n. So I want block to be at rest. Block does not slip. No slip. So what is the condition? Mg must be less than or equal to mu s n. Okay, understood? So mu s n must be greater than mu s n must be greater than equal to mg. So n must be greater than equal to mg by mu s. Mg by mu s. Note down. So minimum normal force is this mg by mu, and f and n equal, so f must be, you can write n is equal to f, so f must be greater than or equal to mg by mu s. Mg by mu s. Okay, so remember this formula, mg by mu s. Let's solve some questions. So suppose I have 2 kg block and mu s value is 0.3. So what is the minimum value of this force? Tell me. Mg by mu s. So how much force is required? Mg by mu s. Calculate. Mg how much? 20. 20 by 0.3. Okay, 200 by 3. 200 by 3, 66.67. Correct? 66.67. Suppose you have 3 kg block. 3 kg block is there and mu s is 0.4. So what minimum force is needed? Horizontal force is needed. Horizontal. Okay. Horizontal force. Minimum horizontal force how much? Mg by mu s. 30 by 0.4. So 300 by 4. 75. Okay. 75 Newton. So suppose this book is 3 kg. This book is 3 kg and mu s value is 0.4. Mu s is 0.4 and this book is 3 kg. Now I am exerting force. It is not falling. It is falling. It is falling, correct? So how much force I have to exert? Minimum. Now how much I am exerting? Calculation. What is the value? 75. So how much force I am exerting? Now 75 I am exerting. If more than 75, okay. Less than 75, no, not okay. It will fall. Less than 75, it will fall. Clear? So exactly 75 you have to exert to keep it at rest. To keep at rest. How much force is needed? Mg by mu s. Like this we will do some more questions. Okay. So now two blocks, let's discuss two blocks. Two blocks, one on surface, one hanging. One block on surface, horizontal surface, and one block hanging with the help of string. One block hanging with the help of string. Okay, so draw diagram. Now two blocks. Till now only one block was there, correct? Now how many blocks? Two blocks. Two blocks. See, so one horizontal surface you draw. This is the horizontal surface, vertical surface. One pulley is there. One block here. String is there, and one block is here. Resting block is M1, hanging block is M2, and this is rough. This is rough surface. Okay. You remember that elephant and rat. So suppose elephant is there, and here pulley is there, and rat is there. Rat is there. If surface is smooth here, so elephant will slide or not? Yes, good. So rat is very less mass, but still elephant will slide because tension will act here. Tension act like this, correct? Even a small tension is there, elephant will move because it is a smooth surface. Are you getting? Who can stop it? Who can it stop it? Rough surface, friction. So now it is friction is there. So for this block, what is downward force? M2G, upward force, tension. For this block, what is the rightward force? Tension. Okay, string is there. A leftward force, friction. So friction is acting. Friction force is left. Okay, understood? Now suppose I want to keep it at rest. To keep it at rest. So what is the condition? Keep at rest. What is the condition? T must be equal to friction. Both are equal. So T is equal to friction. Note down. It is at rest. So T is equal to friction. And we know that T is equal to M2G. Correct? T is equal to M2G. If this is at rest, so this is also rest. Because this is not moving. So this is also not moving. So balance. So what is the value of friction? Tell me. M2G. So friction is M2G. So friction is M2G. Okay. Whatever is weight of this block, friction is equal. Suppose weight is 10 Newton. So what is the friction here? 10 Newton. If weight is 20 Newton, so what is the friction here? 20 Newton. If this mass is 3 kg, 3 kg. So how much friction here? 30 Newton. 30 Newton. Good. So friction is M2G. Okay, clear? After this you write, but maximum friction is mu Sn. Maximum friction is mu Sn. And what is n value here? N value M1G. So what is the maximum friction? Mu S M1G. So right now the friction is M2G, but maximum value is mu s M1G. So we can say M2G must be less than or equal to mu s M1G. Okay, so this GG cancel. So M2 must be less than or equal to mu s M1. Note down. M2 must be less than or equal to mu s M1. So this is the condition. Okay, remember this. Memorize this in your formula diary. Also, write down, very important. Okay, so you can check mu s value also. What is mu s value? Mu s must be greater than or equal to M2 by M1. Mu s greater than or equal to M2 by M1. M2 by M1. This by this. Rat by elephant. You can memorize like this. Mass of rat by mass of elephant. Rat by elephant. Okay. This mass by this mass. If mu s is less than this, it will slide. If mu is less than M2 by M1, block M1 slide. Block M1, it will slide. Okay. This is mu s. Okay. Mu s is less than M2 by M1, it will slide. Okay, clear? See, it is all steps. First, you have to understand. It is. I want to keep it at rest. So rest means tension and friction equal. This is also rest. So tension M2G equal. So friction and M2G equal. Friction and M2G equal. But maximum friction is mu s n is M1G. So maximum friction is mu s M1G. Right now the friction is M2G. And M2G must be less than or equal to mu s M1G. GT cancel. So M2 less than or equal to mu s M1. So mu s is greater than or equal to M2 by M1. So mu s greater than or equal to M2 by M1. Correct? Clear? Mu s greater than or equal to M2 by M1. So now I will give one question. You just tell me the block at rest or not. Suppose this is 3 kg. And this is 4 kg. Sorry, this is less. Suppose this is 2 kg and mu s value is 0.8. Now you tell me the system is at rest or not. System means the blocks. Blocks will move or not. Okay, system will be at rest or moving, not rest. So this is M2, this is M1. Okay, so what is M2 by M1 here? 2 by 3. What is that? 0.61. So it is at rest or not? Tell me. Rest, correct. And mu s is 0.8. So 0.8 is greater than 0.67. 0.8 is greater than 0.67. So mu s is greater than M2 by M1. So it will be at rest. So the block is at rest. This is also at rest. Okay. Okay, finish. Now suppose if I interchange it. Interchange. Here 2 kg, here 3 kg, and mu s is 0.8. Tell me, the system will slide or not? Slide. Now this is M2, this is M1. So M2 by M1, 3 by 2. So 1.5. And mu s is 0.8. So mu s is less than 1.5. 0.8 is less than 1.5. So not rest. So not at rest. Okay. So it will slide. It will slide. This will move right side. This will go downward. So friction will act. Kinetic friction will act. Correct. We can calculate acceleration also. Suppose mu k is given 0.6. So the system is not at rest. So we can calculate acceleration. So here what is the force here? 30 Newton. Here tension. And for this what is the force right side? Tension. And what is the force left side? Mu kn. And what is mu kn? How much mu kn? Calculate mu kn. 0.6 into 20. 0.6 into 20. So that is 12. Correct? So what is the pulling force here? 30. And what is the stopping force here? 12. So what is the net force? 30 minus 12. Correct. Very good. So 30 minus 12 is equal to ma. Total mass 5a. Correct. This is the net pulling force. Net pulling force. So here 30, here 12. Okay. So 30 minus 12 is equal to net mass, total mass into acceleration. So 18. 18 is equal to 5a. So you have acceleration is equal to 18 by 5. How much? 3.6. 3.6. Okay. Or suppose you want to use Newton's second law properly, you want to use, you can use that also. What you write here? 30 minus t is equal to 3a. And what you write here? T minus 12 is equal to 2a. Then you can solve this. Now you can solve this. Understood? Add. If you add this, you will get. Add. If you add dt cancel, 30 minus 12, you get same. 30 minus 12 is equal to 5a. Okay, finish. So it is there in your MCQ also. This one, page 29, question 50. Now one more question is there, this 2014, page 45. Okay, solve 50 also. First you solve 50. This one. Page 29, question 50. What is the question? You have this book, everyone? Hmm. This is the question. Here pulley is there. One string. Here block B. Block A. Mass of block A is 2 kg. Coefficient of static friction for A and the table surface is given 0.2. Okay, solve. Note down, note down. So what would be maximum mass of block B? Maximum mass of block B. So that two blocks do not move. Maximum mass. Find maximum mass of B. Find maximum mass of B so that blocks do not move. So formula, you know, what is the formula? Mu s. Mu s must be greater than equal to m2 by m1, correct? This is the formula. So use this. Options: 2 kg, 4 kg, 0.2, 0.4. This is 2014 NEET. So tell me, what is the value? Mu s value, tell me mu s. 0.2 must be greater than equal to m2. M2, this is m2. This is m1. So 0.4 must be greater than equal to m2. So m2 must be less than equal to 0. So minimum, maximum value is 0.4. Point. Okay, clear. If more than 0.4, it will slide. It will move down. It will slide right. It will slide right side. This will move right down. Okay. Next. Okay, finish. So this is finished. Now related to this, next topic. Chain is there. Chain, note down. Related to this. Okay, note down. Rough chain. Rough chain. Rough chain. Part of the chain is resting, remaining part hanging. Part of this chain is hanging on horizontal rough surface, horizontal rough surface, and remaining part is hanging, and remaining part is hanging like this. You draw the diagram. So table is there. This is the table. This is the wall. Now chain is there. Chain. You can draw like this. So what length is hanging? Suppose x. X length is hanging and total length is L. So what length is resting? L minus X. Okay. Now it is rough surface. This is rough surface. So now you can relate it with the two blocks. Now two blocks are like this. What mass you assumed here? M1. What mass you assumed here? M2. So M1 is the mass of resting part. M2 is the mass of hanging part. So total mass, suppose total mass is M. So what is the mass of resting part? What is the mass of this resting part? Tell me. M by L into L minus X. What is the mass of hanging part? M by L into X. Note down. It is known as unitary method. Okay. This is known as unitary method. Like price of 3 apples. You go to market. Price of 3 apples is 100 rupees. So what is the price of 5 apples? What is the price of 5 apples? 5 into 10. 5 into 10. Sorry, 5 into 100 divided by 3. So what is the price of 5 apples? 500 by 3. So like this only, when the length is L, the mass is M. So when the length is X, so what is the mass? X into M by N. Okay, this is known as unitary method. So note down. This is known as unitary method. Okay, understood? 3 apples, 100 rupees. So 5 apples, 5 into 100 by 3. 7 apples. If I ask what is the price of 7 apples? 7 into 100 by 3. 7 into 100. Okay, 6 apples. What is the price of 6 apples? 6 into 100 by 3. 6 into 100 by 3. Okay. So when length is L, mass is M. X. Length is X. What is the mass? XM by L. Okay, understood? So when length is X, what is the mass? XM by L. When length is L minus X, what is the mass? ML minus X. So now substitute. So what is the formula for mu S? Tell me, mu S must be greater than equal to M2 by M1. So this by this. So mu S must be greater than equal to. Tell me, what is this by this? X by L minus X. Okay, so this is the formula, note down. So mu S must be greater than equal to X by L minus X. So this is the formula for mu S. Now find the formula for X. Find formula for X. So cross multiply. So mu L minus mu X greater than equal to X. So mu L greater than equal to mu X plus X. So mu L greater than equal to X common mu plus 1. Okay. So mu L by mu plus 1 is greater than equal to X, or you can say X is less than or equal to mu L by mu plus 1. Okay, note down. So two formula. One formula for mu in terms of X and L. One formula for X in terms of mu and L. Okay, clear? So what is the formula for mu? Must be greater than or equal to X upon L minus X. What is the formula for X? Must be less than or equal to mu L by mu plus 1. Okay, clear? So remember this. So x is the maximum length of hanging part. Note down. This is the maximum length of hanging part. X, maximum length of hanging part. Maximum length of hanging part. Suppose mu is 0.5. Suppose mu is 0.5. Tell me, what is the maximum length it can hang? If mu is 0.5, mu s is 0.5. Tell me, what is the maximum length? 0.5 L by 1.5 plus 1. So 0.5 L divided by 1.5. 0.5 upon 1.5, how much? L by 3. L by 3. Suppose total length is 1 meter. So 1 by 3 meter, 33 centimeter. 33 centimeter can hang. Okay? Correct. Good. Okay, fine. So this chain is over. Now solve this question. If maximum length of hanging part is 1/4, if maximum length of hanging part of chain is 1/4 of total length, 1/4 of total length, find minimum value of mu s. Minimum value of mu s. So what is the formula for minimum value of mu s? This mu must be greater than or equal to x by L minus x. You can also write it like this, 1 upon L by x minus 1, correct? You can memorize this or like this. So what is the length of hanging part? 1/4. So what is the x value? What is the x value? 1/4. 1/4 means how much? 1/4. Hmm? L by 4. Correct. 1/4 means L by 4. Visible, right? So x is equal to L by 4. So x is L by 4. You put it here. So what is mu? So mu must be greater than or equal to x is L by 4. You can use this or this. L by 4 by L minus L by 4. 3L by 4. So mu is greater than or equal to L by 4 by 3L by 4. L by 4, L by 4 cancel. So mu must be greater than or equal to 1 by 3. Note down. So minimum value of mu is 1 by 3. Okay, clear? So this is the chain question. Now chain is there. You can memorize like this also. Okay, mu must be greater than or equal to 1 upon L by x minus 1. Okay, suppose x is L by eta. So what is mu? Mu minus mu must be greater than or equal to, what is L by x? L by x will be eta. So 1 upon eta minus 1. So direct formula also you can use. 1/4. 1/4 means 1 by 4. So what is eta value? 4. So mu value 1 by 4 minus 1. If I say 1/3 is hanging, so what is eta value? 3. So what is the mu? 1 by 3 minus 1. Are you getting? One third. One third is hanging. So 3 minus 1. If I say 1/5, 1/5, 1/5 is hanging. So what is eta? 5. So 1 by 5 minus 1. So 4. So 1 by 4. So 0.25. Okay, finish. So this is, so now next you write down. So we will continue half of, up to 11:15. I will continue. So note down. So next, okay, chain is over. Now let's solve inclined plane. Note down. Rough inclined plane. Rough inclined plane. Okay. So now the only thing which is common in smooth inclined plane and rough inclined plane is mg sin theta and mg cos theta. Correct? That you already know. So suppose this is the block. Mass of the block is m. So what is the force down the plane? Mg sin theta and perpendicular to plane. Mg cos theta. This is normal. Correct? Normal is there. Now this plane is rough. So first of all, this is theta. If you increase theta, what happens? If you increase theta, right now what is the theta? Right now what is theta? Give me a pen, any object. That cap is better. Okay. So what is angle now? Angle. What is the angle now? Angle. Huh? 0. Very good. Now I will increase the angle. Is it sliding? Is it sliding? No sliding. Increase angle, increase. Not sliding. Now it will slide. See, it will slide now. Not sliding. No. Now sliding. Why it is sliding? Up to some angle, no sliding. At one angle, it is sliding. Correct? So at what angle it will slide? Okay, that is known as angle of repose. Okay, note down. Angle of repose. So what is angle of repose? What is angle of repose? Note down. Note down. If block is kept on rough horizontal surface, if block is kept on rough horizontal surface, it will not slide. It will not slide. Okay, it will not slide. Why it was not sliding? Because no horizontal force. No horizontal force. Like this. Suppose this is the surface and this is the block. Is it sliding? No, because no horizontal force. Now make it inclined. Make it inclined. Now you are inclining. Now what force is pulling it? Mg sin theta. Mg sin theta is pulling it. Mg sin theta is pulling it down, but it will not slide. Why it is not sliding? Tell me. but it is not sliding because friction is acting. Where friction is acting? Up the plane. So this is the friction, correct? But it is not sliding because friction acting. What is the direction of friction? Up the plane, up the plane. What is this? Mg sin theta down the plane. Friction up the plane. Okay. Now increase angle. Now theta increase. Still not sliding. Still not sliding. Why? Because friction also increased. Because friction also increased. Friction is static or kinetic? It is not sliding. Friction is static or kinetic? Static. So this is static. So if you increase theta, suppose initially theta is 30 degree. What is sin theta? 1 by 2. Now after some time theta is 45 degree. What is sin theta? 1 by root 2 value 0.707. After some time 60 degree. Then what is sin theta? Root 3 by 2, 1.73 by 2, 0.865. Okay. See, angle is increasing, sin theta also increasing, correct? And friction and sin theta, friction and mg sin theta both are equal because it is at rest. Block is at rest. So friction also increasing, but after one particular angle it is sliding. So why? It starts sliding at one particular angle. At angle, suppose that angle is theta. Okay, theta naught. That angle is theta naught, known as angle of repose. Okay, this is angle of repose. So what happens after it is angle of repose? What is going on? Friction reach maximum value. Friction attain maximum value. What is the maximum value of friction? You know it? Tell me. What is the maximum value? Maximum static friction. No, maximum mu s n, mu s n, right? Mu s maximum value is infinity, but maximum friction, what is the formula? Mu s n. And what is the n value? What is the n value? How much n? Mg cos theta, correct? N is mg cos theta. So what is the maximum value of friction? Note down. Maximum value of friction mu s mg cos theta. Are you getting? So note down. Block starts sliding. Block start sliding when? So what force is pulling it? What force is pulling it down? Mg sin theta. What force is stopping it? Static friction. So it will start sliding when mg sin theta is greater than maximum static friction, which is mu mg cos theta. Okay, mg cancel. So sin theta by cos theta. Sin theta is greater than mu s cos theta. So tan theta is greater than mu s. So this is known as angle of repose. Okay, understood? angle of repose. So what is the formula for angle of repose? Tan inverse mu s. Tan inverse mu s. Clear? Angle of repose is tan inverse mu s. Note down. What is the formula for angle of repose? Tan inverse mu s. Suppose mu s is root 3. Then what is angle of repose? Tan inverse root 3 means 60 degree, correct? So up to 60 degree, object will not slide. 10 degree, 20 degree, 30 degree, 40 degree, 50 degree, up to 60 degree, object will not slide. More than 60 degree, slide. If I am giving mu s 1 by root 3, 1 by root 3 means 0.577. Then what is the angle of repose? Tan inverse 1 by root 3. Tan inverse 1 by root 3. How much? Tan 30. What is tan 30? 1 by root 3. So what is angle of repose? 30 degree. So it will not slide. Okay. It will not slide. See. Not sliding. Not sliding. Up to 30 degree not sliding. Okay. After 30 degrees sliding. So angle of repose 30 degree. If mu s is 1. Mu s is 1. Tell me what is angle of repose? What is angle of repose? Tan inverse 1. Tan inverse 1 means tan 45. What is tan 45? 1. So angle of repose is 45. So up to 45 degree, it will not slide. Similarly, mu s is equal to 0.75. 0.75 means 3 by 4. So we know that tan 37 is equal to 3 by 4. So what is the angle of repose? Tan inverse 3 by 4. So 37 degree. So up to 37 degree, it will not slide. After 37 degree, it will slide. Okay, up to 37. Suppose angle of repose 37, and you are keeping at 30 degree. It will slide or not? Angle of repose 37, and you are putting block here at 30 degree. It will slide or not? Not slide. And if you keep at 40 degree, it will slide or not? It will slide. 40 degree means it will slide. Okay. More than repose, it will slide. Equal to repose also not slide. Remember, suppose 37 degree also not slide. Less than 37 also not slide. More than 37 it will slide. Okay, clear? So I am giving one question. You tell me the block will slide or not. Suppose this is 20 degree. Mu s is given. Point 8. Tell me the block will slide or not. You can solve like this. What is tan 30 degree? 1 by root 3. 1 by root 3 how much? 0.577, correct? 1 by root 3, 0.577. So if it is 30 degree, it will slide or not? Suppose it is 30 degree. So tan 30 degree is 0.577, and mu s is how much? 0.8. 0.8 is more than this. So if it is 30 degree, block will slide or not? No. Correct. Good. Not slide. So 20 degree also not slide. 20 is less than 30. Correct or not? So not slide. If I increase this angle, Okay, 53 degree, tell me. Block slide or not? So calculate tan 53. What is tan 53? 4 by 3 means 1.33. So 1.33 is greater than this. So 1.33 is greater than 0.8. So tan theta is greater than mu s. So it will slide. Okay, it will slide. Remember. If tan theta is greater than mu s, it will slide. Block starts sliding when tan theta greater than mu s. If equal to mu s, less than mu s, not slide. You can memorize like this. You can memorize like this. Tan theta try to slide. Tan theta try to slide. Mu s try to stop. Mu s try to stop. So if tan theta more than mu s, it will slide. If mu s more than tan theta, not slide. Okay, clear? If tan theta more than mu s, so it will slide. If tan theta less than or equal to mu s, it will not slide. Okay, like this you remember. Now answer this question. Now mu s is 0.6, mu k is 0.4. Two kg block at rest. Find acceleration. Find acceleration. So first you check it is sliding or not sliding. Sliding. Okay. So 2 kg block is there. Mu s is 0.6. Mu k is 0.4. Okay. Read the question. Rough surface is there. Inclined plane is there. Okay. So block is there. 2 kg. So mu s is given. Mu k is given. Angle is given. So first you calculate tan theta. So step 1. Step 1. Check. Check it is sliding or not. Okay. Check. It is sliding or not. How to check? How to check? Calculate tan 37. What is tan 37? 3 by 4. How much is 3 by 4? 0.75. Mu s, how much mu s? 0.6. Which is more, tan theta or mu s? Which is more? Tan theta is more than mu s. So slide or not slide? So slide. So it will slide. It will slide, so it will accelerate. So friction will be static or kinetic? Kinetic. So friction is kinetic, note down. So friction will act up the plane. Mg sin theta will act down the plane. Normal perpendicular to plane. Mg cos theta perpendicular to plane. Okay. So find acceleration. How will you find acceleration? This minus this. So kinetic friction. Mu k n. Understood? Mu k n. This minus this. So note down. Solve. So how to find acceleration? Mg sin theta minus mu k n is equal to ma, unbalanced force. Newton's second law, that unbalanced force, net unbalanced force is equal to mass into acceleration. Net unbalanced force is equal to mass into acceleration. What is downward force? Mg sin theta. Upward force mu kn. So suppose this is 10 Newton, this is 8 Newton. So 10 minus 8. Okay, like that. So this is the formula. Okay, calculate. Now what is mg sin theta here? How much mg sin theta? Okay. So 2 into 10 into sin 37. So 20 into 3 by 5. So 12. Very good. And what is mu k n? Mu k n means mu k n. N means mg cos theta. So mu k. So 0.4. 2 into 10 into cos 37. Solve this. 8. 8 into 4 by 5. 32 by 5. Friction is 32 by 5. Okay, clear? So 12 minus 32 by 5 is equal to ma. Mass is 2. So ma. Okay, clear? Solve this. 12 minus 32 by 5, how much? 6.4. 12 minus 6.4. 5.8. No, 5.6. 5.6 is equal to 2a. So what is a? 5.6 by 2. How much? 2.8. Okay, clear? How much acceleration? 2.8. Okay, clear? Understood? Now this question is lengthy. If I what I change, so that question is very short question. You decrease angle. If instead of 37 I give 30 here, then what is your answer? If I give 30 here, what is 1030? 1030 value 1 by root 3 in decimal, how much? 0.577. So 1030 is 0.577 and mu s I am giving 0.6. So it will slide or not? No slide. So what is the acceleration? 0. So in this case acceleration is 0. Okay, clear? So this is 37. 1037 is 3 by 4. So it's 0.75. So tan theta is greater than mu s. So sliding. Sliding means the friction is kinetic. Okay. So mg sin theta minus kinetic friction is equal to mass into acceleration. Suppose angle is 30. So tan 30 is 0.577. So tan theta is less. Mu s is more. So not slide. Okay. If mu s is more than tan theta, it will not slide. Okay, clear? So now this chapter is almost finished. So this now you can note down some homework. Now you can solve this common forces in mechanics. Okay, 4.9. So actually few more topic is there. Friction I will teach you. So let's finish today. Okay, because it will go on like this. Okay, so note down. So page 28, question 41. 43, 44, 45, 47. So you can start solving 50, 51, 50, 51, 52, 53. You can solve all questions. Heavy chain question is there, heavy chain, inclined plane, 56, 55. Okay. If kinetic friction is there, then how will you find acceleration? Just you have found acceleration here, right? If smooth is there, smooth plane is there, what is the acceleration in a smooth plane? A smooth inclined plane, what is the acceleration? What is the acceleration? G sin theta. Rough inclined plane, what is the acceleration? Now down the plane, what is the force? Mg sin theta. Up the plane, what is the force? Mu k n. Good. And n is how much? Mg cos theta. How to find acceleration? Mg sin theta minus mu k mg cos theta. Good. Is equal to ma. So mm cancel. So what is the acceleration? G common. G common. Sin theta minus mu k cos theta. So this is the acceleration in rough inclined plane, and this is the acceleration in smooth inclined plane. Okay, you just note down this only. So this question 56, question 56 is based on this. Starting from rest, body slides down 45-degree incline, takes twice the time it takes to slide down same distance in absence of friction. Absence of friction means smooth. Absence of friction. Then use S is equal to half a t square. U is 0. So t is equal to 2s by a square root, correct? S means length. Length of inclined plane is L. Length of inclined plane L. Understood? So S is equal to L. A is G sin theta. Okay, try this question. So 56. Okay, finish it first. Then give me that DC Pandey book. DC Pandey book. Okay. So page 264. You can solve 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13. 1, 2, 9, 10, 13, 14, 15, 16. All questions. Page 279, 64, 65, 66, 63. That one rocket question is also there. Okay, if you have not solved, solve 47 also. Rocket question. '53 also. Okay, finish it. These questions and that also. This also. Okay. This is from PYQ blue color book. PYQ. Okay, so around 10 to 20 questions are there. Okay, more 25 questions are. Okay, so finish it today. Friction not completed. Okay, tomorrow I will continue. Okay, done. Continue.